simplify. So first thing we're going to do, you can either move your exponents or you could distribute the 2 to everything. So let's just go ahead and distribute the 2, and then we'll work with, actually let's go ahead and work inside. Let's do that. Let's work with inside the parenthesis first. So I'm going to move my negatives. So I'm going to move this down, this up, and this up. So I'm going to get 3x y squared y to the third over 9x squared. Now what I can do is I can simplify the 3 and the 9. I can add these two because they're being multiplied. So let's go ahead and write some of this down. So 1x, I'm going to make it y to the fifth over 3x squared. I still need to have my exponent here. And then now what I need to do is I could simplify the x's. So I would do x to the first minus 2 and get x to the negative 1. And because it's negative, I'm going to write it in the bottom. So this will become y to the fifth over 3x. And now I can square everything. So this will become power to a power, y to the 10th, 9x squared. And that would be your final answer. Let's try the next one. Number 2, negative 2xy squared raised to the negative 3 power. Remember, when you have a negative exponent, it's going underneath a 1. So I'm moving everything underneath and then making it a positive 3. Now, what I can do is apply this cube to everything. So then now this becomes negative 2 to the third power is going to be negative 8, and then x cubed y to the 6th. Now you can either write it like this. If you'd rather move the negative sign out front, you can also do that. Let's try one more like this. Next problem is 3xy to the negative 1z raised to the negative 2 power. First thing I'm going to deal with is this negative exponent. Remember, it makes it go to the bottom of a fraction. Nothing else moves. Let me just leave all the other numbers the same. Now what I'm going to do is take care of my negative exponents. And wait, this is squared. All right. Now what I can do is apply the square. So now it'll be 1/9 x squared y to the negative 2 z squared. Now what I need to do is take care of the negative exponent that's here. Remember, to make it positive, move it to its opposite spot. It's negative in the bottom, so I'm going to move it up. So final answer here, y squared over 9x squared z squared.
Why didn't the negative y to the negative second power change to like a positive since you moved it like under the fraction? Why did it stay negative?
Okay, so whenever I'm just working with this, I'm moving the entire thing the way it is and moving it underneath. If you'd rather at the beginning, before you do this, you could have said, well, I'm gonna take care of what's in here, and I'm gonna put the y in the bottom, and then you could flip it to the reciprocal. Does that make sense? Like you could do this. You could have said, first thing I'm gonna do is just take this and move it to the bottom. And then what you could have done is deal with this, flip it to its reciprocal, and now square everything. And make it y squared, 3 squared is 9, and then x squared, z squared. That's another way to do it. All right, let's try another one. This one is going to be 9x to the 4th y raised to the 1/2 over 16x to the 8th y to the 16th raised to the, let's see, what is this? 3/4. All right, so the first thing I'm going to do is apply these exponents to everything. So if I do 9 to the 1/2, so that'll be a 3, and then x to the 4th raised to the 1/2 is x squared, and then this just becomes y to the 1/2. Then in the denominator, I'm doing 16 to the 3/4, which is the 4th root of 16, and then I cube it. So then this becomes 2 to the 3rd, which is 8. Now what I can do is, actually let's make it 1/4. Let's make it a little easier. Let's just make this a 2. We won't do the 3. So then this will become 2 instead of an 8. And now I'm going to do x to the 8th times 1/4, so it becomes x squared. Then y to the 16th times 1/4, and it'll become y to the 4th. Now what I need to do is simplify this. Notice the x's. X squared minus x squared is just x to the 0, which equals 1. So my x squareds are 1s. Then for the y's, I need to do 1/2 minus 4, common denominator. And now I get -7/2. So y to the -7/2 tells me I write the y in the denominator. So my final answer here is going to be 3 over 2 y to the 7/2 power. So don't be surprised if you get crazy fractions on the quiz on Friday. Let's try another one. I know we're running out of time, but just to practice this. So -3.
Wait, I'm confused on something.
Yes.
Why do you have the 7 over 2 in the denominator? If it was negative, wouldn't it be moved to the numerator?
Well, once you do a subtraction problem, if the result of that subtraction of those exponents is negative, it gets written in the denominator. If this were like something like this, then you would move it to the top to make it positive. But when it's the answer to a subtraction problem, if it's positive, you write it in the top. If it's negative, you write it in the bottom. All right, let's do one more. This last one is going to be 3x squared y to the 4th times 2xy to the negative 1 squared. So the first thing I'm going to do is do each individual exponent. So I'm going to do negative 3 to the 4th power, which is positive 81. X squared raised to the 4th is x to the 8th, and then y to the 4th. I'm going to square the 2, put it on the x, put it on the y. So 4x squared, y to the negative 2. Remember, when you multiply exponents, you add them. So I'm going to do 81 times 4 first, get 324, and then I'm going to add the x's and get x to the 10th, and then add the y's. 4 plus negative 2 is 2. All right, I'm going to go ahead and do 6 more problems, and I'm going to post it in this video if you want to see some additional practice. You don't need to finish it. You're going to just turn in your notes that you have now, but I'm going to do 2 more exponent examples, and then I'm going to do 4 square root examples, breaking those down, just for extra practice. So if you want to watch that video, it will be on YouTube. All right, so your homework tonight, okay, here are 2 more exponent examples. So 3xy squared squared plus 4x squared y to the 4th. So remember, when you're adding variables that have exponents, they have to have exactly the same letters and exactly the same exponents. Once I apply this squared to this becomes 9x to the 4th, y to the 4th. Now I have like terms, so now I can just add the coefficients and get 13x squared, y to the 4th. Let's try one more exponent example, and then I'll do a couple radical examples. So this one's negative 3xy to the negative 2 raised to the 3rd power, negative xyz squared. Again, evaluate the exponents individually. Put this 3rd power on all 3 of these. And then now I'll do the same thing over here. I can assume a negative 1 here. Negative 1 squared is positive 1, so that's what happens to that negative sign. And then put the square on all 3 variables. Now I'm going to go back. Nothing to multiply here. You assume a 1, so it's negative 27. Add your x's, and you get x to the 5th. When I add the y's, I get a negative 4. So I'm going to write that in the bottom. And then lastly, nothing to add to the z, so just leave him in the top. And that's that final answer there. Let me do 4 quick square root examples, just to practice. First one is 4 square root 45. Remember, we want it in simplest radical form, so we're going to break the 45 into 9 times 5. If you realize 9's a perfect square, square root it, and you get 12 square root 5. The other one, 2 square root 3 multiplied to 4 square root 2 minus the square root of 5. Again, on this one, I'm going to distribute here to here first, and then here to here, and then I get 2 square root 15, and I'm done. These are not like radicals, so that's your final answer. Do 2 more. 4 square root 27 over the square root of 39. I'm going to reduce this by dividing them both by 3. And then I'm left with 4 square root 9 over square root 13. I can simplify the square root of 9 and make this 4 times 3. I'm now left with 12 over the square root of 13, and I need to rationalize. So I'll multiply top and bottom by root 13. And this gives me 12 square root 13 over 13. And I'm done. Last one is going to be adding radicals. So 4 square root 3 plus 5 square root 27 minus square root of 300. Remember, in order to add and subtract radicals, you need to have like radicals. So let me go ahead and break down the 27 and the 300. Now let me go ahead and rewrite everything else that was still there. All right, so for this one, I'm going to pull out the 9, make it a 3. Rewrite this, square root the 100, multiply this, and now combine all of my coefficients. So I'm going to add 4 plus 15, I get 19 root 3, rewrite that, and now just show that 19 minus 10 is 9, square root 3. So these are just a few extra examples to help you maybe practice a little bit more.